So here we will try to prove this variable here, and then the first one here is to prove that which you have there. So we're taking it, so let's take it this way. Okay, so here the first one actually is to prove that the variance of x plus t, then that equals the variance of x. So in this you can actually start from either the LHS or you start off your work with from the RHS. So this is the LHS and this side is the RHS. So you can start your work from any of those two sides, either the LHS or the RHS. But if you look at the LHS, you see the LHS seems a little bit much more complex than the RHS. So sometimes we always want to work from the more complex side to a less complex part. Okay, so I'm going to take the LHS, so that to be from the LHS, right? So from the LHS, what you get will be to take the variance, which is there, and that is x plus t, right? To take that. Okay, now if you're taking that particular variable, the first question you want to talk about is the definition of variance. Okay, and so you will agree with me that for a typical variance, that it is the variance of, let's say, y equals, you remember how this work, that's not the summation, equals the expected value, right, square minus the expected value or square. Now you remember this pretty much. Okay, so from here, that is our variance, which we've actually proven in the previous video. If you've not watched that, kindly go back to the previous video and try to watch that. And do not forget to like, share, and also click on the notification bell if you've not done so. And if you've been enjoying the video so far, also try to click on the subscribe button. It's free and it's not going to cost you anything. So in that way, we can now, right, introduce the concept. The concept I would like to introduce here is to take this value for this value, right? So I can definitely use this value for this value, and that will be anywhere we see the value of y. We can take that value and instruct it inside for it. So we're going to put this value for that value, and anywhere we see y, we'll put x plus t. Okay, so and this is going to go here, and this is going to go here, and this is going to go here. So we're going to put it in anywhere we see the y variable. That makes enough sense right there. So we can go ahead and work in line with this. Okay, so let's take it up. All right, so here we have it. Now we can take the variable we have here now, will then be equal to, if you look at this now, it will be the expected value, right? And it's going to be what now? X plus t all square. That's crazy enough. All square. And then we can subtract, right? We can subtract the expected value, right, which is just like that, in the bracket of what is coming in. What is coming in is x so what is coming in is the x plus t, right? So we close that and we fix that in its bracket. Okay, so now that we have that, we can therefore move off to the layer, and this we'll continue to solve right now. We want to open the bracket here, so we need to open this bracket, flip it all open, and then if you do that, that will produce you with this into the bracket of x plus t, and of course x plus t. Okay, so we have that, and we can now say minus, right? We tend to open this bracket, so we will get ourselves with expected value of x with the expected value of t, and then we can keep that and square it out. Okay, so from here you're going to be getting this by that x, you get the x squared plus 2xt. If you open the bracket, that is what you're going to get, plus t squared. If you open that bracket, this is what you're going to get. Okay, so guys, you can go ahead and open that bracket on your own. So this will be into the bracket of the expected value of x. The expected value of a constant is definitely going to be the constant, so that's going to be plus t, right? And that'll be all square. That makes some sense. So all I want to do here is to split this around. I'm going to open this bracket, and that'll be the expected value all square plus the expected value. The expected value is only going to operate on x. It's not going to operate on 2t. You remember that? So okay, I know what to do here. It's going to be the expected value of 2xt. Okay, so then plus the expected value of t square. You see that right there? Okay, so this is going to be 2 bracket now, the expected value of x plus t, and in another bracket the expected value of x plus t. Okay, so from here we can make things work out here, as this is going to instruct out as the expected value all square plus here. Now at this point here we are going to have to take 2t outside because they are constants, so we get 2t. Okay, so the expected value of x, then plus the expected value of t square is still going to be t square because it's constant. Okay, so that makes some sense. Okay, so we have now minus. Okay, so now that we get our minus, we want to get this bracket, and that will be the expected value multiplied by the expected value. So if you take the expected value and you multiply that out by the expected value in that variable, they will multiply themselves and we'll get what we want. So the expected value multiplied by the expected value of that x, right, that will give us the expected value of x all square. That makes some sense. So then we want to get the expected value multiplied by t, so that's going to give us plus t and then the expected value, and then we're going to get another, and that's going to be t and of course the expected value, and we'll get the t square. Okay, so that makes some sense right there. So here we'll get the expected value square 2t of the expected value plus t square minus if you open this bracket open, you're going to get all square, then you're going to get minus 2t of that expected value. Okay, then you're going to get minus t square. That's what you get. So here I will begin to cancel out details. If you look at it, take care of that away, and then this t square, take care of that t square. So things get cancelled all out. Okay, so now that things get cancelled all out, you can take it now that the expected value square, right, and then that will be minus the open bracket of, what would that be now, the expected value of x all square. So where we get to, that is it. Look at this point here. Could you see this point? The variance of y equals to this expected value of y square and this of the square of the expected value square. So that was when it was y. So if I have this, it means that this is the same answer as the variance of x. There we go with the answer to that proof. That makes sense. You can try to work out the second proof if you want, and you can pause the video and try to look at what the second proof will look like. If not, you can also follow us as we'll bring out the second proof. So the second proof is highly direct. We have to prove that